So let's talk today about two subjects, exceptions in Java and even more interesting, input-output in Java. So before we jump into these topics, let me clarify small technical detail. So we ask you create packages in your assignments, and so you need to pay attention how to create exactly that packages in JavaFX project, so everything will work okay. So first of all, pay attention that we have this root package, and I propose you to create not a siblings but children of this root package. So you create your packages inside this package and put some, wherever you need inside of that specific packages. But one more thing you need to do. You jump into file module info Java, and by default you will have this line there, your high-level package, which been created at the very beginning. But when you create additional packages, do not forget to put them also into this section. So export them, they will become available to run as a separate application, let's say. So you see main package and then this child package, and the same for the next one. Okay, this is just small detail.
Is it necessary that the package should be called com, that comments something after that?
No, this is good question. Do we need to name it like this? It is like website backward kind of domains. So this is a common approach to make domains, yes, backward. It could be org, your organization name, your project name, and so on. However, you could put anything there, even without these dots, and that will still work. So this is just, some naming approach.
Just naming conventions.
Yeah, name conventions. Okay, so our first subject, exception handling in Java. What is exceptions? Exceptions, when we talk about exceptions, we talk about exceptional situations when our program is running. So what is exceptional situation? Simply saying errors. When you encounter some error in your program, how your program will react to that error? Will it just crash and stop, or there will be some error handling, exception handling, maybe some user-friendly handling, or even user will not know anything, but your program will not crash and your program will still function. So this is a topic about that. Basically, when error rise in our program, Java platform will throw some kind of error like an object. We call this object exception object. And like any other objects, exception objects have its own class hierarchy. So we have object at the top or at the root, then throwable interface, and then we have different abilities like error and exception, which we could basically handle. When we talk about errors, just for your information, it is internal Java errors or operating system errors. So we do not handle these problems. This is not our fault when these problems arise. But what is the main focus of our attention? It is compile time, or how we call it, checked exceptions. We could check that exceptions, and we could react for that exceptional situation. So for example, we open we try and our program, for example, have specific data storage module. We call it, for example, I don't know, so something.txt, records.txt, and our program will work only when this file is present within our program. But maybe someone came and just deleted that file. This is not our fault. This is some outer powers come and delete that. But we could handle this problem. So we're trying to open that file does not exist, and what? This is exception, error. And we could handle this exception and say, oh, our database is broken, sorry, see you next time. Or something like that, not just crash, you know. This is, we could do on the level of this compile time or checked exceptions. So for different situations, we know in advance that there could be exception, like file open, reading, writing files, the very basic situation for that. Maybe open databases and other stuff. So, and Java require us to react. Oh, do not forget that this file could be not present, so you need to react to that possible situation. So please write specific code to handle that. And even compiler or Java will require you, hey, no, please put exception handlings here. That's why we call it compile time exceptions. So even compiler will require you to handle that and will ask you, oh, I know this situation, you should handle it. But there is also runtime exceptions. We don't need to react to them like, exception handling, but these runtime errors, they occur because of our mistake as programmers. So for example, division by zero. This is our algorithmic problem if we made it in our program. If we had such arguments and we didn't check them, or our algorithm written in such a way that that could be, division by zero. Or we write a code and trying to access array element. I believe all of you encountered that error in previous course when you're trying to reach element which is not present in this array with index which is more than number of elements. And this is our problem. We should not handle this array. Oh, if I make mistake, then I handle this mistake in such a way. No, just don't make this mistake. Just don't reach element which does not exist. And we call this runtime exceptions. Java still will throw that exceptions, but this is a message to us as a programmers that we should not have this kind of error at all. Okay, let's jump into syntax. Unchecked exceptions. As I said, this is what could happen if we create program in bad way. So for example, we create a string variable. Even without null, it will be null, basically, here, if we do not initialize that. So for example, let it be null even here. And we're trying to reach that variable and call method of string, like length method. Of course, it is not possible because there is no such variable not initialized. And we will have null pointer exception here. And you could read that exception in your console when you run your program. Example with array, we have 5 elements starting from 0 to 4 and trying to access 5th element, which is basically number 6, and not present in this array. And what we will have this lovely exception index, array index out of bounds exception. And division by 0. If you try to run this code, you will get this arithmetic exception in your console. Okay, so what we need to handle these exceptions, we need to change our code. We need to change our algorithm. But let's move to checked exceptions, compile time exceptions. So as I already said, we could access some file, and we believe this file should be present. But it is not in our authority to guard presence of that file. And there could be such possibility that file is not present or something bad happened when we read the file. That's why we should basically create this syntax to catch exception. So we have this syntax, and let's pay attention to that. Exception handling starting with word try. Like, I will try do this operation. This operation could lead to exceptions, and we tell it with try. Then we have this block of code, and there could be exception. So when basically I'm really interested why is this scanner close not, oh yeah, this is while and this is, yeah, absolutely correct. So, and we run this code, and if there would be exception, then catch clause will be called. And here in this brackets we have exception parameter. So as I said, it is just object of type file not found exception, for example, like here. And we could react somehow. For example, print into console, or even show dialog, or anything else, or log this exception for future our investigations. So try, catch. And second variant, how we handle exceptions, it is if we run something which could throw exception, but we don't want to put try catch inside this specific block of code. And we just say, oh, we will throw it on the above, just to method which called us. And we just throw this exception, propagate this exception to next level, to previous level of hierarchy of our, let's say, back stack or call stack. And that means that method which called this particular method should somehow then react, or also throw that exception. Okay, so please just remember this, and I will show you more examples. So more detailed observation of try-catch syntax. Basically, we could have not only try and catch, we could have try and multiple catch. So we could catch exception of this type, file not found, for example, then exception of this type, input-output error, and so on and so forth. So we could, one by one, check that exception. So when exception occurs, it goes through this, think about that like a switch case. It goes through this kind of switch case, and when it type is similar or equal, then this block of code will be run. But not only try and catch, but also very useful stuff like finally. And what that means? So for example, you try to open the file, and you basically did it. And you try to read from file, and then some exception occurs, some problems with hard drive, or I don't know, something. But when you open the file, you utilize some resources. Your program utilizes some resources. And if exception occurs and you just, oh, sorry guys, and move on, and do not close, do not free that resources, that could be a problem. Your program could consume some operating system resources or computer resources. So it is very important when you utilize, when you open some resources, you should close that resources. So finally, really helps us to do that. So even some exception will be here, we will close that resources in any case. And this is very good approach to do things. So let's pay attention to this real example. So we create a file reader variable. Then in try block, we're trying to create this file reader accessing my file txt. Then we try to read data. On this level or on this level, there could be exceptions. We don't know exactly. That could happen. We should handle them. So we try to handle that. First, catch file not found exception. So this is on this level. And we do some stuff. Or input-output exception. Then it could come here. But after this catch, if exception occurs, and this catch just run, after that, in any case, there will be also this block run. So what do we have here? Unfortunately, we have one more try catch block, which I could say it makes code even more awful. But nevertheless, we have this finally block, and we're trying to close our file reader here. So this is the main point of this finally. We have it, and we know that in any case, we will try definitely to close this resource. Still, even here could be some exception. But yes, I should admit, guys, this is just awful. This code with try catch it makes cyclomatic complexity. As we said, it inner blocks, these brackets, and yeah, this is not so beautiful, but still we need to do that. We need to do that, but not be very paranoid regarding exceptions and not to try make everywhere try catch. If you could handle this problem somehow, maybe check something before doing that, or even send some specific return value of the method. It is also possible how to handle errors. But still, yeah, we need to utilize try catch. Yes?
Just a side note from like the production environment. If you're doing the transaction, always finally revert all the changes.
Okay. Regarding transactions. Okay. Yes.
I have two questions. First of all, what happens if, for example, it throws file not found exception? Does it throw input-output error if, for example, there is also an error with input-output?
Yeah, good question. So let's jump a little bit deeper into that. So basically, file not found exception is class which derives from I/O exception. So I/O is a superclass for this, if I'm not mistaken. But this is a good question. So if we want to work specifically with this exception, then yeah, what runtime environment will do? It checks first of all first catch. If first catch satisfied, then that's it. It will not run to next catch. So basically, this is a good question, and that's why more specific exceptions we should put higher in this catch list. Because if I put I/O exception first, then I will never reach this, because it is superclass and it always will work first.
And second question: how does throws work? Like, does it throw an error every time, or I don't get it? Or it doesn't work basically right, like try and catch?
Throw. You mean for method?
Yeah, for method.
Yeah, I will have just in a few slides example of that. Yeah. But before that, let me also comment this, I could say, wonderful addition, syntax sugar, we could say, that have already. I have some, I just jump into chat and see that Ion asks, unchecked exceptions are exceptions that we cannot ignore. Yes, of course, we cannot ignore, for example, division by zero. We should write our algorithm in such a way that we will not have that. So, but basically, we do not need to try catch division by zero exception. So this is different way how to handle exceptions. For unchecked exceptions, which we should write correct algorithms. For checked exceptions, we should write try catch or throw code. So what I like, oops. Sorry, this is shortcuts stuff. So again, my favorite painting tool. So I really like this try with resources statement. What that mean? What the difference? Pay attention. In this case, we basically, in most cases, don't need finally. But let me explain you. You see the difference here. So try to or find these differences. What the difference between general try and this try which I show you? What the syntax difference? Yeah.
Has parameters.
Yeah, exactly. It has kind of parameters, something like parameters. So let's jump into that. Arsene is right, and we have this brackets here. And inside the brackets, there is some code. So it is not parameters, it is just general code. So you see, we just write code, put semicolon, write another code, and so on. So it is just specific place for specific code. But what that mean? That means that any exception, any resources which could throw exception, when they opened here in this section, they will definitely closed. If exception arises, then Java inside there under the hood will handle that exception and definitely close the resources. This is good news. So we don't need to put this boilerplate here and put if resource is not null, that try to close that and so on. So it is much more better. So that's why you just put it here, and then you could catch error. Yeah, you could react for that error, but you know that these resources will be closed.
And I see that finally isn't used really.
Yeah, and we even don't need to use finally. So if we, in most cases, we use finally just to close resources. If we need to use final to maybe not only close resources, but also do some business logic, we could add finally. But in most cases, we don't have that business logic in finally. That's why here we even don't need that. So try, open file reader, open buffered reader for this file reader, and then catch IO exception, and we don't need finally. The same here. How it could be, in most cases, we will write just this code. So let's pay attention to this. We just create, basically this is our next subject, how to open files. But you know that it is very connected with exceptions handling. So we open file reader, then we put parameter of file reader into buffered reader. Buffered reader optimize file reading. So if you have very huge file, that buffered reader will read chunk by chunk, and it is very optimal from the point of view of performance of your program. So you just read this file in buffered reader, but basically you have 2 points of possible exceptions, here and here. But all this stuff is inside brackets of try. That's why that resources will be closed despite any exceptions. Then you just do your work, handle exception just for program perspective, maybe print some message, show dialog, or make some login, and that's it. Okay. And regarding Igor's question, exception propagation, we call it, when we don't want to put try catch inside our method, then we still need to throw that exceptions on above level. So basically it works the same way. So you see this throw exception, but method which call this do something will need to make try catch or also throw that exception above, and so on and so forth.
So it should like print the message of the exception every time, or
You could print that message. You
Yeah.
could do nothing.
okay, so
You could do anything you want. And if you didn't catch it everywhere, then it come to your main method, and your main method throw exception just to system.
so I just try to understand.
And then your application will just crash.
I just try to understand like how does it work? How does it work like every time? So if, for example, I have this exception,
Okay.
I have the exception type 1 and I have throws exception type 1. What happens, for example? Or input out exception. So I have this exception.
Yeah.
And what does it write?
So your program overall meet exception. That's what that means that program could not function in, further. It need to react to that exception. So it try first. Do we have exception handling inside this method? For example, not. We throw this exception on previous method. Does previous method have exception handling? Not. Okay, go to another previous method, and so on and so forth. But no difference in what place, but somewhere we for example, have this catch block. We catch this exception. We maybe print something into console, and after that, program will handle or manage next instructions. So you will just go on. So maybe you just your method is over, and then it comes to previous method, and that method some new instruction, and program will work on.
So basically throws like it does throws it to the next level.
Yeah.
Okay.
Yeah. Okay. So this is it regarding exceptions.